Okay, hey, welcome back. Now let's do 563 binary tree tilt. I read through the question problem statement once and I read through it properly because when I went through it first time, I read through it wrongly and I was left wondering why my solution is not working, where I went wrong in life. Is there any way I can come back on track? Yeah. And then I read through the problem statement carefully and thought, yes, I know where I went wrong in life. I did not study English properly, mainly because I can't read English. Oh yeah, that will happen to everyone. So yeah, read through it properly. You are given the root and you are asked to calculate the tilt of every tree. You have to calculate the tilt of every node. My God, English is hard. And yeah, what is tilt? Tilt is the absolute difference between sum of all left subtree nodes values and right subtree node values. Yeah, first I read it as sum of all left tree node values and right tree node values, and I thought, yeah, what I can do is I can check for 4. I can check. I can just take the value of 9 and 2 and subtract it and put it over there. For 2, I can subtract 3 and 5, put it over there. For 9, I can subtract 7 and 0. Yeah, and because they have given that. If there is no left or right child, then treat that value as 0. So yeah, I thought I could directly do 7 minus 0 is equal to 7. So in place of 9, it will become 7. And I thought it was working. For the bottom two nodes, it worked, and I thought it would work for top node also. But when I went through it, I understood it was wrong. And so I read the problem statement properly and I got to know what to do. And yes, so what you have to do is for every node you have to just do any kind of traversal. First what you have to do is to get every node you have to do a traversal, and then for again each and every node you have to do another traversal. So yeah, it consists of two traversals. I think that itself speaks to its complexity. It will obviously be of n square, where n is the number of nodes, because at worst case, if you have a complete tree, then you have to go through each and every node again twice. So yeah, it's pretty simple. Yeah, you can do any kind of traversal to get the nodes, and I am obviously opting for my favorite, which is level order traversal. But hey, you can do any kind of DFS or BFS. Just make sure to implement it properly. And yeah, let's directly get on with the code. Yeah, let me define a level order, which will take in the node. And yeah, obviously, if you know, you have to be able to write this with your eyes closed. So this node over here, not root. And you have an answer variable over here. And yeah, there is a chance that there is no node. Then if there is no node, then you have to return 0. So yeah, you add the value of the node to the answer. And if node dot left exists, then and then now you can calculate on the answer. And now what you have to do, now we have to go through each node once. So yeah, have a tilt variable, and again you have to define another DFS function to go through each node. And then while q exists, node is q dot. Now what you have to do, yeah, this is the part where you have to do the level order traversal of each node. Yeah, level order or any kind of DFS, BFS, any FS solution. So yeah, on node dot left and node dot right, what you have to do, you have to do the level order traversal. So yeah, just let me select these things. Yeah, let me enclose them in brackets. And yes, let me write the definition of the function, which is level order, not ordered. And yeah, what you have to do, yeah, just store it as the left subtree sum and right subtree sum and right. Yeah, and yeah, what is the definition of tilt? It is the absolute difference of the sum of left and right subtree values. So tilt is equal to the abs of Yeah, this minus this. Yeah, just read what the problem statement once properly. It is the absolute of this minus this, and yeah, and yeah, your depth first search is not yet over. I mean breadth first search. Level order is the breadth first search solution. So if no dot, it's not. Yeah, I call it as not. So no dot left exists, then and yeah, and now it's over, and you can directly turn the tilt. But yeah, again, read through the problem statement properly. They are given that the number of nodes can be from 0. So yeah, just add a guard clause over here. So if not root, then we will obviously return 0, as you can't find any right or left subset. Yeah, now compile it once. Have I made any typos? Have I made any logical errors? And obviously not. Now let me just submit it once. And yeah, the grind set paid off. Yeah, it might not be efficient, mainly because yeah, again, as I told, lead code uses your internet speed, and my internet speed is not that good. And yeah, the time complexity of this solution is O of n square, because yeah, I explained it once, but I'll tell it to you again. For each and every node, you have to find all the left and right subtrees, which will obviously take the number of nodes again as the value. So the time complexity is n for the first traversal. It is O of n for this traversal, and for each value in this, it is over here. So O of n multiplied by n, which is O of n square. And yeah, so yeah, this is it. And thank you. Grind more DSC, you can do it.